Hello lovely people. Today we are going to look at Euclidean geometry as it involves proportionality theorem. Proportionality theorem. Now we are given this equation. They gave us that AE is x over 2 plus 1 and AF is equals to x plus 2, FB is equals to 24, ED is equals to 3x, and DC is equals to 12. Now they are asking us to show, using the proportionality theorem, that ED is equivalent to CD. In a nutshell, they are asking us to prove that this is 12 as well as this. Now, how do we go about it? We use the proportionality theorem, which says that if two parallel lines are involved in a triangle, then those two parallel lines will divide the lines proportionally. Remember, proportionally, this is different from midpoint theorem. Midpoint theorem divides equally, but this divides proportionally. Under midpoint theorem, yes, we have two parallel lines, but this will be the midpoint. E will be the midpoint of triangle ABD. F will be the midpoint of triangle of this line AD. E will be the midpoint of line AD. But in this case, if it is not given that E is the midpoint and it's not given that F is the midpoint, you cannot use the midpoint theorem. That is where we go to the proportionality theorem. And the proportionality theorem says that the line divides them proportionally. What do we mean by proportionally? What we mean here is that in this case, AF all over FB will be equals to AE all over ED. That is, AF will be equals to AE, FB will be equals to this, and our reason is line divides line parallel to one side. Line parallel to one side because the line is parallel to one side of the given triangle we are working on. Please, we cannot work with the entire triangle, we only work with the one that is parallel. The divisor is parallel to its base, and that is why we are only working with triangle ABD. We can't work with triangle ABC because the base BC is not parallel to any of the divisors. The only line we can also work on, another triangle we can also work on is triangle FEC, because this line is also parallel to the base of that triangle. But let's start with this. Now, it means AF means that we have x plus 2 over FB, which is 24, being equals to AE, which is x over 2 plus 1 divided by ED, which is 3x. Please, we have algebra here. We cross multiply. We cross multiply because there are two fractions being separated by an equality sign. Now we have 3x multiplying this. We have 3x squared. 3x into this is 3x squared. And 3x times 2 is 6x. That is what we get from here. And then let's go through here. This will give us 24x divided by 2, which is 12x, times 24. 24 times 1 is 24. This is leading us to a quadratic equation, so we rewrite this and equate it to 0 before we can solve. So we have 3x squared, 6x, minus 12x gives us minus 6x, minus 24 equals to 0. We can reduce this further because 3 is a factor of all the numbers, so I can have x squared minus 2x minus 12. Sorry, x into 6 is 2, x into, 3 into 24 is 8 equals to 0. So divide it all through with 3, because 3 is a common factor here. To reduce the expression, it gives us the same answer. So 3 here, 1, 3 here, 2, 3 into 24 is 8. Now we can factorize this and solve for the values of x. This is factorization. We are looking at two numbers that we can multiply to give us the last number and add the same two numbers to give us the middle one. So let's look at negative 4 and positive 2. Negative 4 positive 2 will give us negative 2. Negative 4 times 2 will give us negative 8. So these are the factors. X will be equals to 4 or x will be equals to negative 2. We only need one value of x here. So we have to do our critical check here. Critical check, if we plug in negative 2 for x here, we have 3 times negative 2, which is negative 6. ED is a length, and a length cannot have a negative value. So we have to reject that x cannot be negative 2. X cannot be negative 2, x can only be 4. If x is equal to 4, remember ED is 3x, then we can comfortably say that ED is equals to DC. Why? Because we have 3 times 4 is equals to DC, which is 12. So we have proven using Euclidean geometry and a touch of algebra that ED is equals to DC using the proportionality theorem. You have to know this theorem. Remember, it has corollaries, and that is that AG over AF can also be AG equals to AD over AE, and so on and so forth. So this is the solution to our problem. Remember, continue to follow our pages, continue to subscribe, share the video. Help your friends, support your friends, encourage your friends to come on board. I am here to help you. Good luck.